This is Note-Taking Guide 7.3 for Mathematical Decision Making for Life. Today we're going to talk about a Hamiltonian pattern or path. So what is a Hamiltonian path? Well, when we looked at Euler's path the other day, they were focused on looking at each edge just once. Another way to look at networks is to consider visiting each of the vertices just once. Named after Sir William Hamilton, we now look at Hamiltonian paths and Hamiltonian circuits. A Hamiltonian circuit is a circuit or a cycle that visits each of the vertices once and only once and ends on the same vertex point that it began. For example, in this network, the Hamiltonian circuit is marked in red. So you go A, B, C, D, A. And we got to every vertex point once. We started at A and we ended at A. That's the circuit, when you start and you end at the same point. If you notice, just to kind of point this out, just to make sure you're understanding the difference from what we did yesterday, we didn't have to draw over that edge right there. The edges are not important today. It's only the vertices that are important. Okay, so a Hamiltonian path is a path that visits each of the vertices once and only once, but can begin and end on different vertices. For example, the Hamiltonian path in the network here could be A to B to C to D to E. Now, there definitely probably could be more than one path to do this, but this is one path that works. And again, just a reminder, we didn't actually have to touch that edge because we're only worried about the vertices this time. So here it says, can you find another Hamilton path? So let's look and see what we can do. So before on this path they did A, B, C, D, E. So we have to do something different than A, B, C, D, E. So let's maybe try, let's go A, B, E, D, C. Again, we hit every vertex on the route, but we didn't have to hit every edge. So we did A, and then we did B, and then I can't remember what these are. I have to erase the vertex points so I can see them. So we did A, B, E, D, C. So it was just in a different order of the same vertex points, and that's totally fine. You can probably do several more. Unlike with the Euler paths, there is no single rule or theorem to help us identify if a Hamiltonian path or a Hamiltonian circuit exists. The only thing we can do is to look for them. The following network has both a Hamiltonian path and a Hamiltonian circuit. Can you find each? All right, so a path, again, does not have to begin and end in the same spot. So lots of paths. I could go this path right here. I can go B, A, D, C. Now, you guys, that's just one path. You could have picked a different one, very easily picked a different one even. Okay, so now I have to do a circuit, which means I have to stop and start in the same spot. So I think I'm going to start in the middle here and go D, A, B, C, D. That lets me start. So I started at D, I went to A, B, C, and I ended back up at D. So my circuit started at D and it ended at D. All right, next example. Is it possible to draw a Hamiltonian path on the following diagrams? Well, again, we just have to try it and see. So a path can start anywhere we want it to, and it can only touch each vertice once. So that path that I did didn't work very good. That one's not going to work. That's not going to work. Let's think this through for just a minute. All right, keep trying until you get it, or until you decide that there cannot be one. There we go. I did it. So yes, this one can have a Hamiltonian path. This one, though, I can't see that happening, because no matter what, to get to C, I have to go through A. So I can't go two directions on this one. This one I'm definitely going to say no right off the bat on that. Again, you guys, there's no for sure way to know. We have to just keep guessing and checking until we find them. All right, this one says a mailman is planning his route to a certain, using the graph below. So A represents William, B represents Ivan, C represents Vincent. We're just using that down there to tell us who represents who. Part A here says the mailman starts his route at William's residence. So William is A, so he starts here at A. He wants his route to be time efficient by passing by each house only once. Is this route possible? So he can only go by every house once. So how about he goes just like that? So we went A, B, C, D, E, and F. That was a Hamiltonian path that got us from one spot to the next, passing each house only once. Part B says, if he has to start at William's house, given the path of the mailman, should follow by listing the vertices separated by commas. Oh, so it's just asking us. So I guess on the first one we were just supposed to put yes, it was possible. On the second one we were supposed to list the vertices with a comma in between them, which we did already up above. Okay. So you guys, that's how we find a Hamiltonian path or circuit. Pretty simple, actually, not too bad. So remembering this time we're looking at the vertices and not the edges. Thanks for watching. Good luck with your homework.